the daily space for July 9th, 2018. I'm not sure how good my bit rates are going to be. I'm currently coming to you via a cell phone connection. So I'm going to work very hard not to move and to send you information at, unfortunately, the lowest bit rate possible in hopes that the information, well, will get out no matter what the internet may be trying to do. After all, the show must go on. Now, luckily, today is a slow news day, and I'm going to focus, internet willing, I'm going to focus on a bit of historical astronomy. On this day, back in 1979, when I was just 5 years old, this spacecraft, Voyager 2, flew past Jupiter. It was on the second mission of discovery that we ever sent to this gas giant. I remember this particular event because it was considered so important back in 1979 that network television live broadcast the data coming in. I remember this because my parents made me take a nap in order to stay up late and watch the data, and I did not want to take a nap because at 5 I was a big girl. Well, now, many, many years later, we perhaps won't discuss how many years later, although you can all do the math, we still view the data we got at Jupiter from Voyager 2 as the start of great science. So I'm going to highlight some of the many discoveries that we made so many years ago. So the first big discovery that we got was with this particular mission, we were finally able to get high-resolution images of Jupiter's Great Red Spot. You can see it with a small backyard telescope, but the details aren't that great. Now, with this particular mission, we got better views, better resolution, and, more mysteries revealed than anyone could have expected. Now, in addition to studying the surface of Jupiter, we also studied its environments. Again, by we, I mean other humans. This was work done by, Carl Sagan was part of the mission. Carolyn Porco, who worked on the Cassini mission, was also part of these Voyager missions. I was 5. I was not yet in kindergarten. But today, I continue to look at these images as, what got me started in my interests in space. Now, the big discovery that I think confused and shocked a lot of people was that Jupiter has these Gossamer rings, ring structures that are so small, so faint, that at the time we were utterly unable to perceive them from here on the surface of our planet Earth. I apologize for all the dropping frames. Again, I'm currently trying to go out over cellular. I'm going to remove the chat in order to try and conserve bandwidth. So I apologize for killing the chat. I'm hoping this will help the content get out a little bit better. Okay, so here we are looking at the Gossamer rings of Jupiter that once again were discovered by the Voyager 2 spacecraft. Now, in addition to this discovery, the Voyager 2 spacecraft was able to follow up on many of the great discoveries that were made by Voyager 1 earlier. Now, I'm still dropping bandwidth. I'm still dropping frames. To those of you watching live, I am going to do a second recording of this episode that will actually be recorded and then uploaded to both YouTube and Twitch. I apologize. Okay. This is a bandwidth issue on my end. I apologize. So in addition to the discoveries of the rings, we also did follow-up observations of Europa. With Voyager 1, which being one got to Jupiter first, scientists were able to see what appeared to be cracks in the surface of Europa. But with this particular follow-up mission, they were able to see that these cracks weren't so much deep cracks, deep crevices were what we were seeing with shadows, but rather these are surface cracks that showed differences in the coloration of the surface and the texture of Europa. These particular features would continue to be a mystery until the Galileo space probe in the late 1990s was able to do follow-up work and help us understand that Europa actually has a constantly evolving surface that floats atop a deep, warm ocean. Following on, we also had observations of Europa in a bit lower resolution. Not Europa, of Io rather, in a bit lower resolution that was able to show that this particular, strange and blotchy world has ongoing volcanism. On a regular basis, on a daily basis, volcanoes all across its surface continue to erupt, continue to wipe away craters and add new features. We are still trying to figure out all the amazing tectonics, but we've been able to document since 1979, almost 40 years of data, exactly how this surface continues to change. So beyond those two moons, we also had brand new images of the great moon Ganymede. This particular moon is actually larger than Mercury. And quite surprisingly, it is the most beat up of all the moons of Jupiter. Now, this may not be a strictly historic factor. Rather, it could be that all the moons have had similar amounts of impacts occur, but this one world is the one that surface gets, redone the least often. With Io, we have volcanism that constantly spreads new lava out across the surface, erasing any craters that may have formed. With Io, we instead have with Europa, we instead have this constant resurfacing that occurs as new liquid flows out across the surface. And as its icy tectonics cause, one plate or one ice section to sink beneath another, causing instead new stuff to show up on the surface, again, erasing craters from the past. With Ganymede, we now believe it also may have pockets of subsurface seas, but it's not the same kind of icy surface. Instead, its surface, which appears to be a mix of ice and rock and other materials, is, just sitting there, preserving the history of cratering that has taken place. Now, Jupiter continues to be a place that missions set their eyes upon. This particular spacecraft has, not this particular spacecraft, this particular planet has been observed over and over, and we will continue to send new missions to it into the future. First visited in in December 1973, right before I was born, Pioneer 10 sent us back our first tantalizing images. It was revisited again in December 1974. We had Voyager 1 visiting it in January 79, only to be followed up later, by Voyager 2. Now, Galileo got there in December 8th, 1995, and since then we've continued to send many missions on paths that would allow them to catch images of Jupiter as they continued on to completely different destinations. The Ulysses mission, for instance, on what may be one of the farthest ranging orbits that, well, I've had a chance to look at, other than maybe the Rosetta. The Ulysses mission, which was on its way to study the sun, did a swing past Jupiter on the way. Cassini, on its way to Saturn in 2000, sent us visions of Jupiter. And New Horizons, as it traveled out to Pluto, took a moment to pause and look at Jupiter in 2006. Now, Juno is currently there today. We continue to get new and spectacular images and new and incredible understanding. It arrived there on the 4th of July in 2016. So July, it turns out, is a good month if you want to study Jupiter. Our next big mission to this particular system is likely going to be the Europa Clipper. We don't have an exact launch date right now, but it's looking like perhaps at some point in the 2020s, we'll have a new mission studying Europa and giving us up-close views of this particular world. Europa Clipper is going to orbit, well, Europa. It may or may not be carrying a little lander that will take its chances and touch the ice. We have a lot of decisions to make before we send that Clipper. It's not just a matter of what will the budgets allow. We also have to consider, well, what if there's life beneath the surface? How do we sterilize a spacecraft? How do we sterilize a lander to protect that potential life, well, from all the problems here on Earth, whether they be extremophiles, viruses, or anything else that might, well, act to kill off life that we haven't yet seen? Well, stand by, and as these decisions are made, we will bring them to you here on the Daily Space. I greatly appreciate all of you tuning in and staying with me as I've dealt with all of our technological struggles today. As I said, I will be later today recording a new version of this show that will be just the content part and will hopefully allow you to see it in, well, the high resolution, high bandwidth that you deserve. I will be uploading those files both to here on Twitch and also to our YouTube station, where you can catch every episode if you happen to miss the live recordings. Now, I will attempt to take your questions. Please at me in the chat. And I'm going to switch views to host only. And I seem to be getting a little bit better bandwidth, so hopefully this will continue to work. This does appear to be a composite problem of both my home internet and Twitch. I switched over to cellular and it was still being twitchy for a little bit, but it seems to be holding rock solid now. So as Paranor points out, please at me so that I will notice your questions in the chat. So I see Paranor is making the comment that it's our big helpful sister. Well, since Jupiter is actually named after the god Zeus, just using the Roman name instead, I think Big Brother might be a better term, although Jupiter is free to choose whatever gender it pleases and identifies with. Now, I have heard a lot of people say that Jupiter probably protected us from a lot of incoming rocks and comets. Well, modern theories show that Jupiter was probably just as likely to throw rocks at us as it was to throw them out of the solar system and protect us. So perhaps a bratty, bigger sibling, not necessarily older, but definitely bigger, is a better way to look at it. Sometimes this big sibling protects us, and sometimes this big sibling just likes to throw snowballs and rocks. So Big J is saying, Oh, so yeah, you need to highlight me, and I'm sadly at CosmoQuest and not at Pamela. I do see your question though, thanks to Big J. So, Ziori is saying, do scientists still think that there may be an ocean of water under the surface oceans of methane? I actually don't know about that, so I'm afraid I can't answer. One of the problems that we deal with in astronomy and space science is there's literally hundreds of new papers coming out every single day, and it's pretty much impossible to keep track of everything. I do what I can, but I'm afraid I occasionally miss some of these results. This is why we have Google. I'd encourage you to give that particular question a Google. We do know that there are methane ethane seas on the moon Titan, which orbits Saturn. I don't know if there's any theories that there may be water at higher pressures underneath. So Kaymore is asking, so are the moons Europa and Enceladus very similar? Similar enough so that we could study one and possibly understand both. They are quite similar worlds. Both Europa and Enceladus are ice covered with what we call tiger stripes on Enceladus. These are large cracks in the surface that we know that fluid escapes through. We see ice geysers, and the Cassini mission was able to actually sample some of the fluid, well, ice particles tossed up during one of these geyser eruptions. This is a form of cryovolcanism. This material, we now understand, contains many of the organic compounds that are compatible with life. We haven't had the same opportunity to sample the materials coming up from Europa. We're hoping to be able to do that with the Europa Clipper. Now, while these are similar worlds and understanding one of them does help us understand the other, they aren't identical worlds. It's kind of like Mars and Mercury are both probably solid most of the way through. They're both covered in craters, and understanding the physics of one of these mostly atmospheric-less worlds. Thank you so much for the subscription, Bundy. That's greatly appreciated. Understanding one of these worlds does help us understand the other, but due to differences in mass, due to differences in the tidal effects that they get from the different worlds that they orbit, they aren't identical. So they each have overlapping stories, but the stories aren't identical. So thank you so much. So Hanny is asking, are there any plans for ways to make super clean probes, like 3D printing in a vacuum or dipping the probes in some kind of disinfectant? The idea of building things in space is definitely something that we're working toward, but we're not going to be there on the right timeline for the Europa Clipper mission. We do have people that are working to solve the how do we disinfect things problem. This is a matter of using alcohol, using clean rooms, using radiation to disinfect different kinds of, well, components in the spacecraft. Not everything can be safely radiated. Not everything can be safely wiped clean with alcohol or another solvent. It's definitely a challenging problem, and there are people working to solve these challenges. So I see Fenrig asking, do we know how Mercury ended up with a relatively large core and overall high density? It's generally believed that this may have been due to either an impact that tossed away all of the surface material at some point in the past, or that while it was still forming, its surface materials may have been literally blown away by intense flare activity in the sun. We don't yet have all the answers, but we have theories that help us explain what are the options that we need to explore with continued missions. There's often multiple solutions that fit low-resolution data, and additional data is needed to hone in on exactly what is happening. Looking to see 2 data sets to assess, a third might work. It's always a matter of more and more data sets are needed. So I'm afraid I do have multiple people coming at me with questions from all directions that are in the real world and not in this chat. So I am going to need to end this stream on time today. As I said, I am going to re-record it and bring you the information, with a better bandwidth. So thank you all for coming, and as always, The Daily Space is a production of the Astronomical Society of the Pacific, working in collaboration with the Planetary Science Institute and Youngstown State University. We are part of CosmoQuest, presented to you by the staff of CosmoQuest. If you want to be part of exploring our solar system, please click over to cosmoquest.org and help us map out other worlds and find the safe places to land a spacecraft and the scientifically interesting places to explore. Thank you all for coming, and please, we are sustained by you. Every subscription helps, and every bit really matters. Thank you for coming, and I hope to see you with better bandwidth on the other side. Wherever in the world you may be, have a fabulous morning, evening, or afternoon, and remember, look up. Bye-bye.